Hello, I'm Kip Sigmund, a consultant for TypeSafe, and I'm going to introduce you to case classes in Scala. I'll start by walking you through a typical Java class and show you how to implement the equivalent functionality with a Scala case class. And after that, I'll show you some of the other neat features of case classes. I have Eclipse IDE open, and in my left pane, I have the source for a Java class called Java User. And you can see this functionality has already been implemented. And in my right pane, I have a Scala source for a class called Scala User, which has yet to be implemented. I'll walk through all the functionality in the Java User class, and as I cover each piece, I'll implement it on the Scala User class. Lines 3 through 11 in my Java User class defines a field called name, and a constructor to set that name, and a public accessor. You'll also note that this final key modifier on name makes name immutable, which means it can only be set on construction of an object but never modified for the rest of the lifetime of that object. To accomplish the same functionality on my Scala user, I'll start by adding a constructor, which I do by just adding a set of parentheses after the class name. And I'll define a class parameter called name of type string. And this would now be available if I were to define a body of the class, and I could do things like this. And the body of a Scala class is the same as the body of a default constructor in a Java class. So, although that might be useful, it's not really what I'm trying to accomplish. What I'm trying to accomplish is to create an immutable, publicly accessible field. And I can do that by just adding this val keyword in front of name. This is now immutable and publicly accessible, and it's a field. This is called promoting a class parameter to a class field. I could have also done this by adding the keyword var, but then name would be mutable, which means it could be changed after an instance of this class was created. And it's highlighted red because my IDE is warning me to use immutable variables wherever possible. So I'll change that back to val. Lines 13 through 25 of my Java class is implementation of something called the builder pattern. The purpose of this is to easily create instances of Java user using default field values. I could have also done this with constructor overloading, which would probably be fine for a class with one field, but if I were to add more fields later, the builder pattern is a much better approach to go. And you could look that up on the internet and study the reasons why. But this builder is basically an inner static class. It has a default value. You can override that default value, and here's your factory method. So how can I accomplish the same thing in Scala, which is to be able to easily create instance of Scala user with default value for the name field? I can do that by simply defining a default value for that field right where the field is declared. And I could now call this constructor with no arguments and it would use this default value, or I could call it with one argument and it would use that and assign that to name. Now, all Java classes inherit from Java object, which has an equals method on it, and this default implementation of this equals method uses something called identity, which means if you were to call equals between two objects, it would only return true if those two objects were actually the same instance of the same class. And that's not really useful in most real-world applications. What I like to use is something called structural equality. And what that means is I'd like two Java users to be considered equivalent if they have the same values for all their fields. We only have one field called name, so I'm using a third-party library called Google Guava to help me with the equals implementation. And you can see I'm passing it my one field name on both this and the other object passed in to implement this. Now, because I've implemented an overridden version of equals, I also have to override hash code. And this is to meet the equals hash code contract in Java, which states that if two objects are considered equal, they must also have the same hash code. So I've overridden hash code. I've used that Google library again, and it has a helper to create the hash code. And I pass it the name here. And I've also overridden toString because the default implementation of toString on a Java class is to return the class name and the address. And that's not really helpful either in logging and debugging. So what I'd like to do is return the class name and the values for each field. So again, I'm using a Google helper here, and it'll create a nice, more friendly version of toString for this Java user class. So this is quite a bit of functionality, and I've used a third-party library to help me. And how could I implement all this in the Scala user class? Well, my immediate inclination is to create a body and start defining overridden methods, but you don't need to do that in Scala. And this is where, if we simply add the word case in front of this, we suddenly get a lot of additional functionality. And this now becomes what's called a case class. And three of the features we get for free are a sensible implementation of equals, hashcode, and toString. That essentially match the functionality that I've written here in my Java class. So if we now sum up, these two classes are essentially equivalent, and the Java class is 50 lines long, and my Scala class is 1 line long. Oh, and I should also mention that when this became a case class, it automatically promotes all class parameters to class fields, immutable class fields. So I can get rid of this val keyword. It's redundant at that point. Or you can leave it in if you prefer. Now, to demonstrate a little bit further how the case class can help you with boilerplate coding, let's go ahead and add another field to this Java user class. Let's say I want to add a field called email of type string. So add it there. I'll add a constructor argument, and I will assign that constructor argument to the field. And I'm already getting a little bit tired of typing, so now I'm going to use Eclipse IDE to help me generate my public accessor for email. And okay, so I've now got that. And I look down and I can tell my builder is now broken, so I'll need to create a default value for email here. And if I want to be able to override that field, I'll have to create another method called email here. And you could probably tell at this point it'd be very easy for me to create a typo or forget something. And I could accidentally assign my email value to the name or something silly like that. And then I'll add email down here. And okay, and now I know I'm going to have to change my implementations for equals, hashcode, and toString. So let's say it's pretty late in the day, and I fix my hashcode implementation, and I'll fix my toString implementation. And I've accidentally forgotten to fix my equals implementation. All right, now if you're paying attention along the way here, you'll notice that I've introduced two major problems and potentially a lot of other smaller problems. The first problem is that when this class was only one field and that field was immutable, the class was immutable. But I've now introduced a field called email, and I forgot to make it immutable. So the class is no longer immutable. And although there's no way to change the value, there's no publicly available method to do so at this point, another team member could come along in a couple days and easily add one because I've not really shown my intent. So I'll fix the first problem by making that final, but you can see that could have been easily forgotten. And the second big problem I've introduced is that I've broken the contract between equals and hashcode. Because I forgot to change equals, if I had two Java users with the same name and different email addresses, they would return true for equals, but they would have different hash codes. So let's fix the equals method too. And if you're like me at this point, you're probably getting pretty tired of typing. And I may then again forget to change this to email. Or the point I'm making is that it's very easy to introduce a lot of bugs that won't get caught at compile time and may not even get caught during your initial round of unit tests or debugging. Let's go over here and do the same thing to our Scala user class. Now, I want to be fair to the Java class, so I'm going to turn this into a multi-line class now so it's more readable. And I'll add this new field. And that's it. So in about 15 seconds in Scala, I was able to accomplish what took me probably in the neighborhood of 5 minutes in Java. And it's very unlikely that I introduced any bugs over here because my overridden equals hash code and toString will automatically adjust to handle this email correctly. I also don't have a dependency on this Google Guava library in my Scala user, which is another benefit. And my Java class is now 64 lines and my Scala user class is 3. So as you can see, reducing boilerplate, avoiding bugs, and getting free functionality are some of the great things about case classes. Now, let me show you a little more what you can do with them. I'm going to open a Scala worksheet here, and I'm going to kind of hide my class files. And I've already started this off just to show you what it would look like to construct the Java users. And this should look pretty straightforward to you. Here's a new Java user. Here's using the builder. I had to create an instance of builder and then call build on it. Let's create a Scala user. That's it. The first thing you'll notice is that I didn't use the new keyword. That's another feature you get from case classes, is that you can create new instances without the new keyword by using a factory. It's basically creating an associated companion object of the same name as the class with an apply method. This is the same as this, but you don't need to specify that. And the constructor arguments will be the same. And because I passed no constructor arguments, it used my default values. Now I could also create this by specifying both those values, which is pretty much like creating the Java class, but again, you didn't need the new keyword. But let me show you what else you can do. Let's say I want to create it and I want to use the default name, but I want to specify the email. I could then create the class by only with what's called named parameters. So I'm using the default for name and I'm using my own custom definition for email. Another really cool thing you can do with Scala case classes is that you can copy one very easily by just calling this copy method, which you also get for free by using a case class. And in the copy method, you can only specify the parameters that you actually want to change. And what this is doing is what's called an immutable copy. Scala user isn't changing, but we're creating a new instance of Scala user with all the same values except for anything I specify in the arguments to the copy method. So as you can see, that's all pretty powerful. And the real feature of case classes in Scala is to be able to use them in something called pattern matching. And I'm not going to go too deep into that, but I'll just show you a quick example of it. Let's say I have a value, and I may not even be sure what type it is. Or maybe I know it's a case class but of type Scala user, but I don't really know the values. So I can do some matching by doing something like this. And I'll just print out a statement. And I'll explain in a second what this does. Pattern matching in Scala is kind of like a switch statement in Java, but quite a bit more powerful and a lot of additional features. So what I'm doing is I'm matching this. In the first case, I match. What I'm basically saying is if this is of type Scala user, this will match, and I'm also decomposing the object into its component fields here. And I can then use those component fields on the right-hand side. And this is really useful in real-world Scala applications, and you'll see this quite a bit. And that's why case classes are called case classes, is so that you can use them in pattern matching. This second line, this underscore, just means match on anything else. And so if the first line didn't match, then this will match, and because it shouldn't match, I just printed out ugh. But we'll never actually see that. And you can see that the output of this is that it just printed out the name Kip. So that's basically an introduction to case classes, and you can see that it has a lot of powerful features. They can help you reduce boilerplate. You get a lot of functionality for free, and it gives you a lot of helpers for easy modification and creation, and you can also use them in pattern matching and decomposition. Thanks.